Good evening. Welcome to the LAN Tamer stream. This is my agenda for tonight. Got several things to cover. First of all, well, got my shades. First of all, the wallpaper of the day is yet another tribute to the world of Twin Peaks: The Return, which is going to end this Sunday. Sad, sad. This is Laura Palmer from episode or part 2, I think. And want to do a little Q&A. I've got several in the last 1 or 2 days. I've got several questions on both Twitter and Instagram. So want to reply to these on the stream and just also let everybody know if you ever have any questions for me. Feel free to follow me. Well, you can follow me up on the screen up here. You'll see my the symbols for my handles on both Twitter and Instagram. And just to review what I do there, Twitter, I like to announce, make announcements about the stream. Sometimes when I'm about to start a stream, although I'm getting away from that because it seems that most are joining the stream via, just notifications on Twitter or something like that. So anyway, yeah, so that's kind of what I use Twitter for. And Instagram, I do flashcards and other things related to, the stream and labbing, and just sometimes there's funny things I find on there, and that's kind of, it's also used to give news and things about the channel. So feel free to follow me there, and you can ask questions on either platform or in the chat, which that reminds me, I don't think I have the chat window up. So let me put that up real quick in case. YouTube is not the best platform for seeing chats or interacting with chat. That was the wrong link. That was a live link. So yeah, feel free to ask me a question on platforms. And I think I answered the questions already, but I'm going to address them anyway here just in case. Others may also have these same questions. One was about a flashcard I posted. And let me see if I can pull up the actual flashcard from Instagram. Let me make sure this logs into my LAN Tamer account here before I pull this up on screen. And it is. So yeah, on Instagram, there's a question about one of these flashcards. It wasn't the one I posted yesterday. The one I posted yesterday was about, or the day before, OSPF route type preferences. I think this was about access lists. Let me see if I can find that one. Route filtering, I think it was. Let's see here. Yeah, I think this is it. Nope. It was one from a while back. I can't seem to find it. Maybe it says under here. Oh yeah, here it is. So there's a question here from RIPv2 He said, what does this mean? This extended ACL used in IGP, where I had the source is the update source and the destination is the network address. So yeah, I replied basically that there's a YouTube video that shows you how this is used. And essentially how this is used in access control list. If you're trying to distribute or filter incoming routes, you can use an access list, but for a particular route, you might have multiple sources. Well, using this extended ACL feature, this is how you filter a specific route from a particular source. And that would be like the gateway, or, sometimes in the IP and the routing table, it will show you the gateway address or learn from address. This is your router source address, though. You specify that first. The destination will be the actual route that you're wanting to filter out. So, and there's a demonstration of that on this video. I think I did an EIGRP. I believe we did an OSPF as well. But yeah, I appreciate the questions. Keep them coming. I'm happy to answer those. Someone else asked on Twitter, Lantamer, do you use RFCs as part of your study program? I have not yet. It doesn't mean that I won't. I came close to consulting one when I had an issue in OSPF a little while back on how certain LSPF decisions were handled. So, but no, I have not done raw reading of RFCs. Not to say I'm going to rule that out. I think a scenario where I would use an RFC is when I've consulted all the material that I can find on, in the I&E workbook or in the I&E videos on a particular topic, and I still don't understand it. I might search the Cisco documentation. And even then, I might, do a Google search or find other sources just to try to find a simple explanation. Because I realize that if none of those work, then yes, I may go back to reading the actual RFC. And I don't know if any of you have read an RFC before or attempted to read an RFC. They're pretty in depth, so you have to dedicate some time to it. But I think that that's something that I would do if I got to that point. So far, I haven't gotten to that point yet, to a point that is so subtle. The other thing that I do when I have a question that I can't answer or that I don't know the answer to or something that I don't understand, I use the INE Spark group or I'll use the Router Gods River discussion group. I'll go in there before basically RFC would be your last resort. No one has been able to answer this question, and I feel that the time is important enough for me to actually go to read the RFC, and again, that would be a last resort on that. Cisco Live. Someone asked me, do you use a Cisco Live recordings as part of your study program? I do not yet. Well, let me change that a little bit. I have used them in the past. So when I was studying for the CCIE written, and I've not yet passed the written, but when I was preparing through those topics, there were some topics where I just didn't have any material on them. And I went and did some searches on Cisco Live site, and of course you have to, register your email address to get access to it. But they're free, and they're excellent resources. Typically they're done in like a presentation. I've not attended Cisco Live. I plan to in 2018 though, because it's going to be here where I live in Orlando. So, but it's a presentation format. Someone's giving a PowerPoint or giving a presentation, or it's some sort of presentation to that effect. But Cisco Live is great. I mean, they have those recordings. They have people who are involved in the protocol development or the product development in Cisco in the company itself. The people who know are actually giving the presentation. They're not often the best teachers or presenters. Sometimes the sound is not really good, etc. But the content is amazing. And I will say, I may have posted it on this channel. I did actually review a couple of videos recently that had to do with the format of the exam itself. And it was presented by none other than one of the persons in charge of the CCIE route switch lab exam program and administering that program. Excellent stuff. So yeah, I highly recommend it. But again, it is not part of my structured, study program right now. Right now, my main program is the INE workbook. And, in a future vlog or whatever, I'll discuss more of what I'm going to do with that. Speaking of vlog information, vlog topics, I just have one. This comes as a result of my recent call with one of the now subscriber to this channel who just passed his CCIE route switch lab and it just got his number. He recommended reviewing EVE-NG. EVE, not the game, but the open source. I think I've actually downloaded it. I may have downloaded it today. Let me check that. Okay, it's not here. Or it may already be installed. Not yet, but just letting the stream know that right now I'm committed to Viral. I've invested in that. I've got Viral 1.3 working. In the future, I plan to use up the tokens that I purchased with INE rack rental. But barring any of that and going into the the latter phases of preparation for the lab, based on my conversation yesterday, I do plan on looking into EVE-NG, and I'll probably stream the install here one evening, and go through setting it up and just kind of walk through it. I'd love to have it as an alternative also in case I have an issue with viral. I'd love to be able to just keep going nonstop in the lab and have another environment as a backup. So I'll be doing this soon on the stream, and I'll announce it either on Twitter or on here. Links of the day, move right into that. I've got 3 really good ones. One is, if you are not familiar with David Bombal's, I don't know if I'm pronouncing that right, channel, definitely check it out. The links will be in the video description. They're in the live description. I told him I would help him promote his channel. He just hit, I think, 15,000 subscribers. I'm not exactly sure. Great content. And I highly recommend you subscribing to his channel. I do. And I watch the videos as they come out. He has a lot on Python, which I hope to incorporate more myself going in the future. And then this is someone who just attempted the lab route switch and failed it. And it was his first attempt, Matt Haedo, and he blogs about his experience. I don't know if part 2 is up yet, but when it is, I'll post it here as well. Great. There's not a lot of content here. He's just kind of going over his feelings. But in this part 2, I anticipate seeing some more about maybe what he plans to do different for the next lab, which I think he is booked for like next month already. Like he's failed once, but going right back to it, which, hey, that's great. And then Katherine McNamara, if you don't follow her on social media, she's a networking powerhouse. She referenced this in a discussion group today, a blog on the demand for skilled engineers. Question came up about people who do brain dumps, and she has interviewed a lot of people, including people who have their CCIE, and she has some interesting discussion here about how, there's no danger to someone, there's no danger to the future of the CCIE certification, and especially people who have the skills, which there's a lot of lack of. Great read, highly recommend it. And there's another blog too. I did not get a chance to read it, but I plan on posting it tomorrow. I already created an agenda item for it for tomorrow's agenda. Got it in there. Now getting into the lab, what most of you probably been waiting for. We are back on redistribution case number 3. This is the last of the 3 redistribution cases in this section of the INE workbook. Disclaimer, I did not design this lab. This is from the INE workbook. I'm just sharing my struggle on trying to interpret or understand the lab, and that's what we're doing tonight. So let's go ahead and pull it up here. This is the drawing I did on stream yesterday based on the INE workbook, and we have OSPF area 0 here, and we have some overlap, and we've got RIPv2, and we're supposed to, let me see, I don't think I have those notes. I'm going to go ahead and close this stream agenda, guys. We're going to focus on this. We're hitting lab mode engaged, right? So what we have is we have to identify a problem and propose solution, right? Almost sounds like something on maybe the T-shoot part of real world lab, right? So I'm just going to kind of continue my thoughts from yesterday. I don't have a whole lot to add, just basically that what it looks like to me is that, first of all, the fact that you're doing mutual redistribution between protocol domains, but the fact that they're being done on different routers, to me means there's got to be problems. And the other thing I still don't really understand, I have not researched this, is when you redistribute a route from another protocol into RIP, how does RIP know? In OSPF, there's a mechanism to know, right? The mechanism is the database and distinguishing the links by the link type and the LSA type. In EIGRP, it's distinguished by the administrative distance and the type code. When you look at the routing table, show IP route, and you look at the various codes, D and DEX, right? And the administrative distance reflects that this is a route learned from another, an external route redistributed into this routing protocol. So how does RIP handle that? I don't remember, to be honest. I think I did a little bit of that in the RIP section. So I'm going to have to kind of review that before. But to me, without knowing really that there's any distinction, RIP is essentially a hop count dynamic routing protocol. So does this mean that when I bring a route into RIP here, that when it gets to router 6 that it has a hop count of 1 and that the metric is reflected appropriately? And first of all, how does it know if I take these RIP routes, redistribute them into OSPF, and then, well, that's not really going to happen, but it might with this one because, again, this is a point of contention. I don't know. I need to do a little looking first before I can kind of make a judgment about what problems there might be. So let's open up our terminal windows and let's start digging in a little bit. I need to check OBS because earlier I was having an issue with this command window. I got it back now to make sure it's working. It's still a little messed up here. Give me just a moment. We'll get that in position. Okay. That is a little better. I'm behind my head there. All right. So let's look at the routing table on one of these RIP routers. Let's go to router 7. And let's just see what these look like. RIP. Yeah, now see, 150.1.9.9 is redistributed, but there's no way to know that here in the RIP protocol. And it is a distance of 120, so metric of 2, right? So I wonder, do I have RIP routes? I do. 1, 2, 3, 4, 5, 6, 8, 9, and 10. Show IP route 150.1.10.10. Distance 120, metric of 2, redistributing via RIP. So not only has this route been learned because it has been redistributed into RIP, what's going to happen? OSPF is going to redistribute it back. And will that have a shorter distance? No, because OSPF will always prefer intra-area over external routes. So that should be fine. That should not create any kind of loop. So let's do what we learned yesterday with our new command here. And let's check to see if there's any sort of instability in the routing protocol in the control plane. And we can do that via the show IP profile command that we talked about yesterday. And we can run it on all the routers. Just the nature of the issue, the fact that it is a redistribution lab means that there is a problem. There is some problem in the network. We just have to find it. And let's get router 9. Go and router 10. Wrong router. Okay, router 10. There we go. So IP route profile. And it's repetitive, but it gives me a little practice. And what we should see, if we have any kind of problem in the control plane and fluctuation or flapping, we'll see it in the IP routing profile, and we'll get to see which router might be able to point us to the problem, right? Okay, so now we have this running show IP route profile. Now this is one of the redistribution routers. So if there's going to be a problem, it's most likely going to be a 1 or 3. Oh, we've got something going on here. Looks like the rest of these routers are looking okay. Yeah. Oh, there's some fluctuation here on router 6. Router 6 is here. We saw it on router 3. These routers have been up for a while too. I don't know, nothing too crazy. Router 1, it looks like he's happy. Router 2 looks happy. Router 3, relatively happy. Prefix refresh. We've got some refresh going on here. And we know RIP is slow. So we might have an issue on router 3. Router 4 is okay. 5. Looks like the OSPF routers are happy. But we've got some little bit of fluctuation here. And it says prefix update. So does that mean 7? Yeah, over here in RIP. OSPF side seems to be fine. Router 9, yeah. So it looks very subtle, doesn't it? Whatever the issue is, we know it's in OSPF or RIP. So what's interesting to me is if I do a show IP route, let's do route RIP. I'm going to look for these, 16 seconds. Whereas if you look on 26 seconds, this one's 19. IP 7, yeah, show IP route RIP. 8 seconds. So yeah, we definitely got some instability in RIP. The router 10 is fine. He's an OSPF. Yeah. 16 seconds. What could the issue be? So far, I have not really been able to narrow it down to a particular router, but using the show IP profile, I have been able to kind of narrow it down to RIP. At least there's some sort of symptom of an issue in RIP. So the next thing we can do is maybe we can do some pings and see if we can narrow it down. I've got a feeling it's not going to, but let's see if we can narrow it down to a particular link or reach var, ping var, yeah. So let's do this over here in RIP. Take router 6, for example. Nine. It's not happy about 9. Of course, because 9 is being redistributed here. So why would 9 be different from router 6's point of view? Let's look at another router in RIP, exclusively in RIP, 7. Also 9. Okay. So we have an issue with 9. And if we think about this, let's think about how 9 gets advertised. So it's going to go to router 7. Router 7 doesn't have access to router 9. Show IP route. Yeah, he says go to router 6. Router 6 says go to router 1. Okay, so router 3 is redistributing this into OSPF, and then it looks like OSPF, well, no. Let's see where router 1 is learning the route from. Router 3. So we got 1, 2, 3, 4. Where's router 3 learning it from? Router 7. This thing is in a loop, isn't it? Yeah, but we can see that through a trace route. Let's do it from router 7. Trace route. Oh, we got a loop there, all right. So it's going router 6, router 1, router 3, router 7, router 6, router 1, router 3, router 7. So how could this be? Let's sort of draw this out here. So 9 is going to advertise it to 7. 7 is going to advertise it to 6 and to 3. They're both going to advertise it to 1. So I wonder if, what about the order? So let's say, for example, let's say the network is not yet converged. I like this little exercise that Brian McGann did on the INE video the other day. Okay, let's assume the network is not fully converged, but it's stable. Router 9 sends the route to router 7. Okay, then router 7 sends to his RIP neighbors except the neighbor he learned it from. So let's say router 3 gets it. Router 3 does the same. He sends it to router 1. By the way, this should be incrementing the metric, right? It should be 1, and then you should get it as 2. And then 2 is going to send it, should be 3. Now let's say router 1 gets this before 6 sends it to him. Router 1 should then also send it out here. Should be a hop count of 4. Router 6, yeah, I'm not sure what the issue is here. Probably due to the lack of understanding of RIP, which I just kind of breezed through. But you know what? Let's do some debugging here, right? We already know kind of where part of the issue is. So let's move over here to router 7. Debug IP routing. Okay. So what do we have happening here? We're getting RIP updates. Updating RIP via 151.676. Okay, so that's router 6. More updates from router 3. Okay, now these look like regular update messages, but this is a RIB update return code 19. That would lead me to believe that the routing information base, in other words, the routing table, is being updated. And I think we saw that too. Show IP route. Yeah, 8 seconds, 6 seconds. So some sort of churn going on here. 151.9.0. So we should see that on router 3 as well, right? "11 seconds. Let's do debug on that one as well. This issue must be related to redistribution somehow. RIB update return code 17. Updating RIP via router 13.1 from router 1. RIB update return code 19. There's two different return codes, 17 and 19. Don't know what the difference is there. Let me see if I can find something on that real quick. RIB update return code 17. Here's something on the Cisco Learning Network. And nothing there. Not answered. Oh, I think one of them might be flushing a route. The other's adding a route. Okay, so let's pause this. Same on router 1. Updating RIP via... there's a way to see the updates coming, right? Debug, IP, RIP. You know what we should do too is do some Wireshark. Yeah. Let's do some Wireshark. And let's do it from the UWM. Viral. Let's log in as guest. And my simulations. And let's see, yeah, we want to do router 3's GI01 interface. Traffic capture. And let's just do 2,000 packets. Or for fun. Okay, we are getting a lot here though. Received v2 update from router 7. Okay, these are the updates. He's saying you can get to these via interesting. Ignore v2 packet from source from one of our addresses, right? Receive v2 update from router 7. Sending v2 update. Receive v2 update from router 1. One dot one. Oh. Router 1, router 4, router 5, router 8, router 10. Zero zero slash 24. Here's our update from router 3. Or that's sending update, yeah. Wow, 1.9.9 via in 3 hops. One, two, three. Now 1, 2, 3. So I wonder if what might be happening obviously router 1 is sending updates. Get all these routes coming via 3 hops from router 1. Not just the redistributed routes, these routes as well. Okay. So this is what we're seeing on router 3. Let's see what those look like. Our packet capture. Should be done by now. Even if it's not, we can go ahead and take a look. Okay, RIPv2. Let's look at all the RIPv2. I want to apply a filter. Okay, RIPv2, or is it filtering by something else? Yeah, IP source. How would you say protocol? I really have to learn. Let's look. Okay, we're gonna have to look up some Wireshark filters here. This is from the Wireshark wiki. UDP. RIPng. Okay. All right, now we're seeing all the RIP. So source is a destination. So this is router 1. Has sent to multicast destination 224009. And let's see what he's sending. So here are his, interesting, the source port destination port of 520. UDP. And command, response, version RIP, and these are the updates. 150.1.1. Metric of 1. And okay. Is that correct? A metric of 1. So he may inadvertently be advertising. We're inadvertently potentially redistributing the RIP routes that we learn from in OSPF back into RIP. Wait, let's see which ones. Yeah, like 9.9. Is any other router doing that with a metric of 1? Yeah, router 9, these have, that's a metric of 6. Router 3, that's a metric of 1, of course. That looks reasonable. That looks reasonable. So it looks like 3 is actually advertising correctly, but we might have an issue with router 1 and its redistribution. So let's do show IP. All right, let's look at redistributing OSPF 1. It's redistributing, is it redistributing all types? Wow, I did not think it would do that. Okay, probably what we need to do, let's just test this. I know we're jumping right to a solution, but show run router. Metric of 1. That's RIP. Router OSPF 1. Where's our redistribution happening here? Do I have those wrong? Yeah, redistribute OSPF 1 with a metric of 1. Okay. But according to this, yeah, it's redistributing OSPF 1 all network types. That's the problem. So let me paint a picture here. I didn't know it did this by default. and maybe I got this wrong, but it looks like, let's say router 9, for example. Let's use blue because we're in blue, right? Yeah, so router 9 sends here, router 7. Router 7 sends to router 3. Router 3 redistributes this as, we have brown, no, not really. We'll use orange. Redistributes into OSPF as a type 5. Which would be an E2 route, right? And he is the ASBR. So this gets to router 1, and router 1, the redistribution from OSPF into RIP is indiscriminate. All LSA types are being redistributed from OSPF into RIP. So what happens is, now we get back here, and he's sending, hey, I can get to router 9 with one hop. The metric is 1. When that's not good. So we actually, I think what we need to do, yeah, so then 6 is going to say, oh no, I have a better route. And then he's going to send traffic this way. And then router 1 is going to say, 1, 2. Yeah, and then router 6 is going to come this way to get to router 9. And router 1 is going to send the packet. Router 1 is always going to prefer the route through OSPF, right? Let's look at that. So let's see what's in the routing table for router. Show IP route. Yeah. So even though this route originates in RIP, router 1 is in both routing. He's going to prefer the OSPF external route. So he's going to come back this way. Man, this is a mess. Say, oh, I need to go this way to router 3. And router 3, what does he have? His routing table. Show IP route 150.1.9.9. Okay, he's also going to prefer RIP because even though he has an LSA, he's originating it. So he's going to ignore the OSPF routes, but router 1 is not. So he's going to come here, 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 here. But the problem is that router 1 is also going to advertise. He's redistributing this route 1.9.9. He's going to advertise to router 3 in RIP with a metric of 1. So then router 3 is going to say, no, my best route is this way. And traffic's not going to get there. It's a black hole. So I think what we need to do is to somehow, we need to prevent OSPF from redistributing the RIP routes back into RIP. That's just ugly. And is there a way to do that on the command? On the redistribution? Surely there is, even though it is RIP, right? Show run. And that's kind of dumb. I mean, and maybe that's the way, you know, RIP is so limited. Let me not bang on RIP too bad. RIP is not designed to be used this way. I'm going to go, you know, despite my limited experience, I'm going to go out on a limb and say this. Because first of all, it cannot distinguish, like EIGRP and OSPF, it cannot distinguish a redistributed route from a native route. And did I pass it already? Oh, I did include RIP. Yeah. Okay. Now we just did a show run. Can't talk and chew gum at the same time. Sorry, folks. Okay. Redistribute right here. So there's a couple things we could do. Here's possible solutions. Okay. Identify problem. Route 1 is redistributing OE2 routes learned via RIP back into RIP with a low metric of 1. So I guess there's a couple ways. We could increase the metric. Or we could just say router 1, do not redistribute external routes, only those native to OSPF. So let's, the problem with this is what's the maximum metric for RIP? Maximum hop count. Isn't it like 15 or something? So you can't increase this metric too high, because if you do, let's see, what's the maximum? 1, 2, 3, 4. So I mean, I guess you could increase it like 5, and that would ensure that router 1 is never seen as the best route, even though we're redistributing RIP routes back into RIP. But that's just ugly anyway. I think this is the cleaner solution. That's 1, and this is 2. All right, I'm going to do the dirty solution first, just to see if it works. Just to one, sort of validate that we have identified the problem, right? So, and because it's fun. It's fun to break stuff. And then, or even in this case, fix stuff that's broken. So let's do a metric of 5. And we should be able to see right away if, for example, metric changed from 2 to 6. Yeah, so that should make that route uglier. So now if I do show IP route, okay, it's still preferring that metric to router 6. Let's give it a minute though. Okay, now we have 2 equal routes. That should change. On router 9, what kind of metric am I giving it there? I bet we find it's redistributing with kind of a high metric here. Can we do a show run section RIP? Oh, look at that. So we're doing a pretty high metric here, so we'd have to go even higher to fix that. So we could increase redistribution metric on router 1. We could do another combination, really. R1 increase redistribution metric plus lower router 9 redistribution metric. That's a challenge every time to say that. Router 3 and number 3, which I like the best. But let's still play with this, right? So we need to go back to router 1 and bump up the metric. Let's make this 6. Router 7 should never go. That's really the kind of the dirty part of this too. Okay, so now we have a correct. So now everybody should be able to get to it. Let's go all the way over to router 10. All the way to the other side of the neighborhood. Yeah, see now we have reachability. And I'm assuming that the topology is going to kind of stabilize. This took me a while to find the problem, and I think part of it was just I've been working in EIGRP and OSPF now for what, 2 months, and I come back to RIP and I'm like, how does RIP recognize external routes, redistributed routes? Well, it has no mechanism except a metric. That's the only mechanism. So that's why it took me so long to get to this. But anyway, proposed solutions. So those solutions work. The other thing we could do is change this on router 9 and not be so dang high. We could say router RIP, change this, and make this metric. We could play with the numbers, like we can make this 4. Then we would not have to have this metric so high on router 1. It's just some, math here. We could put this back to 5, right? And that should be plenty. Give RIP time to converge. And then the other thing we could do, we can even leave those metrics the way they are. But on router 1, let's go ahead and jump ahead to this option, which is to change the way OSPF is being redistributed into RIP. So what are our options here? I've never really, first of all, I don't think I've ever redistributed OSPF into RIP. Match. So easily enough, I could just do internal, right? We only want to do internal. And we'll leave the metric at, what is transparently? Don't know what that means. But what do we have before? The metric 5. This doesn't matter anymore. Let's put it back to 1. And let's redo this capture. Can we edit it? No, I think we just have to delete it. then do a new capture. This time, yeah, let's go back to router 3. Let's just do, I wonder if this will work. RIPng. And let's do 50 packets. See if that worked. Capture invalid syntax. Nope, didn't like it. Okay, fine. Isn't that what I did on Wireshark? RIPng, yeah. Okay, maybe that doesn't work here. Traffic capture. Let's just do 200. And to see if if we've got stabilization here, let's just check the routing table. It's broke. I think we still have to make the metric right. But let's see what the capture says. I told it to do internals only. All right, let's see what these updates look like. I didn't do enough to catch. I want to see them from router 1. Think we can rerun this? Edit, download, start. Yeah, I want to see what a routing update looks like from router 1. RIPng. That worked before. All right, I got too many files going here. Download. At this stage, the best way to see it may be a debug IP packet. Debug IP routing. Yeah. That. Show IP. See router 7. Show IP route 150.1.9.9. Okay, yeah, this is not right. And it's because the metric is still too low. So yeah, we've got flap, show run. So it doesn't look like it didn't change it. Didn't change it, did it? Router, RIP, redistribute, OSPF 1. Match, internal. Show IP protocol. It doesn't look like that took, does it? It's still distributing these. Internal, external 1 and 2, NSA, external 1 and 2. What is that? We could do a route map, couldn't we? Route map. Redistribute. Permit 10. Match. Route type. Internal. Would that work? Show run section RIP. Did work, okay. Router, RIP, redistribute, OSPF 1, route map, RDist, right? Yeah, RDist, metric 1. Now show IP protocols. RIP, outgoing update filter list for all interfaces not set. It makes no reference to the route map. See if that worked though. Seems to have worked. Router 7. Okay. So now we're filtering. We're matching only internal OSPF routes going this way. So that should do it, folks. That should fix the problem. Man, not a well. It's I don't guess it's a bad use case for RIP. It's just not a good implementation. What we're seeing. Let's go ahead and do a final check just to make sure that we're doing this correctly, and let's check the TCL script. Close that. Clean that up. Yeah, let's just run a quick check on here. Yeah, we're good. I think we're good. And router 10. Yep, Good stuff. And then let's look at router 3. No IP route profile. IP route profile. Feeling it's going to be stable now. All right, folks, well, that takes care of, I believe, redistribution case number 3. Here's what I'm going to do. I'm going to, tonight or tomorrow, I'm going to go back and watch the video, the INE workbook video that discusses a solution, and how Brian McGann identifies the problem. I'm going to go over that. And then tomorrow, I think what I'm going to do, tomorrow will be Wednesday. I feel like I need to go back and do some review before I go into BGP. BGP will probably start on the weekend. And it's a holiday weekend too. But I think what I'll do is take maybe Wednesday, Thursday night to do some review, both of RIP, EIGRP, OSPF, to review and go back and redo some of those labs, etc. And then the weekend we'll start with BGP. Also probably start to watch some BGP videos. Anyway, I'll keep you posted here on the stream. Thanks everybody for joining. Please like and subscribe to support the channel if you enjoy these, and we'll see you back in the lab tomorrow night.